So in this video we're going to look at calculating the concentration of solutions in the unit grams per decimeter cubed. Now this is where the problems start with calculations like this, is because nobody has heard of this unit decimeter cubed. So let's start with that. To start with, decimeter is a unit of length, so centimetre is 1/100th of a metre, okay, whereas a decimeter is 1/10th of a metre. Okay, so what is a decimeter? It's, if you like, 10 centimetres. Okay, deci means 10. Okay, so it's 10 centimetres. So what we need to know now is to do concentration, we need to have a unit for volume. So the volume of water that we're going to add to a solid to make the concentration. If we've got a little bit of water, the solution will be very concentrated. If we've got a lot of water, it will be a very dilute solution. So we need a unit for volume. Now the unit for volume we use in calculations in chemistry is the decimeter cubed. The unit for measuring in the laboratory, we often measure in centimetre cubed. So we have to be able to convert centimetre cubed into decimeter cubed. Okay, so a decimeter is 10 centimetres. So next question, how many centimetre cubed would you fit in a decimeter cube? Well, if you know a decimeter is 10 centimetres, a decimeter cube is 10 centimetres that way, it's 10 centimetres that way, and it's 10 centimetres going backwards. And you can make the cube now, can't we, if we want to draw it out. I'm not great at drawing cubes, never was a great artist, but we'll have a go. So there is my cube. It's 10 centimetres by 10 centimetres by 10 centimetres. 10 centimetres multiplied by 10 centimetres multiplied by 10 centimetres. 10 times 10 times 10 equals 1,000 centimetre cubed. So a decimeter cube, a decimeter cubed, okay, is going to be 1,000 centimetre cubed. Now, if you don't understand this bit over here, that's fine, but you have to learn. You have to learn in chemistry that there are 1,000 centimetre cubed in a decimeter cubed. You have to learn that because these concentration calculations are impossible if you don't know it. So, got an example here. The question says, what is the concentration in grams per decimeter cubed? It's written like this, grams per decimeter cubed. The per is the minus before that 3. You could write it like this, grams per decimeter cubed. And that's without the minus, but it's got that per, that dividing sign there. Okay, so that minus means per. What is the concentration in grams per decimeter cubed of sodium hydroxide solution made from 25 grams of sodium hydroxide in 250 centimetre cubed of distilled water? Okay, so there's two stages to this calculation. The first stage is we have to get the units right because we want the concentration in grams per decimeter cubed. Decimeter cubed. Okay, but the question has given us 250 centimetre cubed. So how do we get centimetre cubed into decimeter cubed? We divide it by 1,000. So the first step is to convert a centimetre cubed to decimeter cubed by dividing by 1,000. So 250 centimetre cubed divided by 1,000, 0.25 decimeter cubed. After that, we need to work out the concentration. And the formula for that is the unit. The unit helps us, grams per decimeter cubed, or per is divide. So it's going to be grams divided by decimeter cubed. Grams per decimeter cubed. So divide the mass of NaOH. The mass of NaOH was 25 grams. So it's going to be 25 divided by the decimeter cubed. Now we work that out in step 1. So that's how we do those calculations. Okay, so we've got some questions beneath here. And that's what we're going to do. So work out the concentration of each of the following solutions in grams per decimeter cubed. We've got 50 grams sodium chloride in 0.5 decimeter cubed. Well, these units are already in the right form, aren't they? We've got 50 grams and decimeter cubed. Grams per decimeter cubed we want. So grams per decimeter cubed. Grams divided by decimeter cubed. That's going to be 50 divided by 0.5. Okay, let's stick that into a calculator and see what we get out. 50 divided by 0.5 equals 100. Answer there is 100. So there is our answer. Equals 100 grams per decimeter cubed. Now notice the way I'm writing it. Grams dm minus, that means per. Grams per decimeter cubed. Next one, 2564 grams. Okay, divided by 2.6 decimeter cubed. The units are right here again, so it's simply grams divided by decimeter cubed, grams per decimeter cubed, 2.6. Let's stick that in the calculator. Let's see what comes out. So 2564 divided by 2.6 equals, let's get that into a decimal, 986.15 grams per decimeter cubed. Well, I'm just going to report that as 986 because we've got no, we have got a decimal point there. So let's do 986.1. 986.1. What am I saying? 0.1. I need to round, don't I? 0.2. Close. 0.2 grams per decimeter cubed. Next one. 20 grams of barium chloride and 50 centimeter cubed. Okay, this one's a little bit harder because this is not in the correct unit. So step one, we have to get that in decimeter cubed. How do we get into decimeter cubed? Divide by 1,000. 50 divided by 1,000. So let's do that before we do anything else. You probably don't need a calculator to do this, but I should just stick into the calculator so you can see exactly how we're doing it. 0.05. So 50 centimeter cubed is 0.05 decimeter cubed. That was stage one. We've now got that in decimeter cubed. Now we need grams divided by decimeter cubed. 20 grams divided by 0.05. So let's cancel that off. 20 divided by 0.05 equals, that's coming in at 400 grams per decimeter cubed. 400 equals 400 grams per decimeter cubed. Next one, 250 grams silver nitrate, 5,000 centimeter cubed distilled water. Again, this is not in decimeter cubed. We need to get this in decimeter cubed. So 5,000, how do we do that? We divide it by 1,000. 1,000 centimeter cubed in a decimeter cubed. 5,000 divided by 1,000 is 5. Again, if you don't believe me, let's stick it very quickly in the calculator. 5,000 divided by 5. Sorry, what did I say? 5,000 divided by 1,000 equals 5. Okay, 5 decimeter cubed. So now it's grams per decimeter cubed. So that's going to be 250 grams. 250 grams divided by 5. Well, that's going to be 50, isn't it? But let's stick in the calculator just to prove it. What did we say? So it's 250 divided by 5. 250 divided by 5. 50 grams per decimeter cubed. Last one. 2.75 kilograms in 3,000 centimeter cubed. Now both of these are in the wrong units. Okay. So we're going to need to take our 2.75, okay, and multiply it by 1,000 to get grams. Okay, so there's 1,000 grams in a kilogram, and we've got a kilogram. So let's do that first. 2.75 by 1,000 is 2,750. Okay, we're going to need to take our 3,000 centimeter cubed and put it into decimeter cubed. To do that, we need to divide by 1,000. Okay, equals 3 decimeter cubed, and now we're going to do grams per decimeter cubed. Okay, grams divided by decimeter cubed. 2,750 divided by 3. Stick that straight in here. 2,750 divided by 3. 916.667, so 917, let's round that to, equals 917 grams per decimeter cubed. And that's how we do calculations on concentration, the unit grams per decimeter cubed.